Hey everybody, I welcome you all for the session on fun with AI. We'll also be discussing a lot on what's going to be there as a fun factor in learning something for us in AI, and also there are a lot of other things that we might miss out sometimes. And I think thanks for Priyanka ma'am for covering almost of what Azure can offer in the ML field. And I think today is the last session on fun with ML, AI and ML part. I think there are many more sessions to come, but yet in this series that we had, this was a last session finally. So yeah, folks, this is all yours and enjoy this session completely. Before that, let me just give a quick intro about my community, AZ Dev India, and Azure Developer Community, which is actually building us in order to be the future ready engineers, in order to learn, network, and upskill. And we have 9,000 plus strong members, a lot of upcoming events as well. And some more events yet to be added from AZDev Bangalore. So watch out on this upcoming sessions. We will be coming up with a lot of sessions there. And also, a lot of past events were pretty well. And also, you can just go and check out them and watch now. You'll just be redirected to that URL. And also, there are a lot of partnering communities. And also, you can join us in any of the communities that you want to really join. The nearby communities can just join with us and make sure that you also learn with us as well. So, over to you, Priyanka ma'am. The stage is yours.
Cool. So, are you sharing my screen?
Yes, ma'am.
Okay, fine. Alrighty. Hey guys, welcome. Final session in our series, and until now. So let's see if we can come up with a bit more advanced analytics, advanced ML kind of sessions later in the year. All right, but yeah. So no AI discussion would be complete without the mention of Auto ML, right? So all these while we have been looking at AI offerings, we have been looking at cognitive services, AI as a service, video analytics, reinforcement learning, transfer learning, building blocks of ML with the help of NLP and stuff, right? But as is the trend right now to have no code or low code NLP models, right? So which I think which was also touch based with me on the podcast which we had, like no code low code is the trend these days. So no AI ML cognitive services cloud computing offering can really be complete without discussion about Auto ML, right? So I think, when we say fun with AI epic wins and fails, I would not so much touch upon the AI fails as much as I want to touch base on the AI wins with the help of Auto ML. So we'll be seeing three different flavors of Auto ML today: one with the help of ml.net, one with your Azure Machine Learning Studio, and one with your custom vision, right? So let's begin. Right, so just quickly, AIMLDS again, the last session which we are doing. So very elementary that we need to understand when we use AI, when we use ML, when we use DS. So AI is like your making machines closer to humans, so implanting or imbibing artificially intelligence into machines, so making them think or making them act like humans would in a particular situation. Machine learning, of course, is the way by which you implant AI into machines, right? And data science is the statistical libraries and other ecosystem which you use to train your machine learning models so as to generate artificial intelligence. Okay. So we will just look at what is ML.NET, fundamentals, FAQs, demo, and when we look at the ML.NET, right, we'll also touch base on. I mean, when I do the demo, we'll also touch based on classification models using ML.NET, object detection, and we'll also look at the Azure Auto ML. All right. So when we look at what is ML.NET, so it's like, it's a .NET machine learning library for C# developers. So for example, as a full stack developer, most of us will need to some or the other time onboard onto our data science machine learning journey, and then it's like a totally reskilling for a .NET or a Java developer, right? I mean, you have to actually start doing a Python and learning the Flask libraries, Python libraries, or Spark, PySpark, right? So why not bring the convenience of machine learning programming into a framework and a language which you already have known, right? So like we saw in the quantum machine learning, you could program with Q sharp. So much the same, a similar way when we are programming for machine learning, you can do that, do those, bring forth those libraries in C sharp, .NET Universe, and that is for the .NET developers, right? So it's built for .NET developers. You currently the support is for C sharp and F sharp, right? And then it basically lets you reuse all your C sharp skill sets, and then lets you build machine learning models in the .NET ecosystem. And those models, mind you, are then can be consumed like in any other application, right? So once the model which you've built, that the model file is much like your job lib or your pkl file, right? So it's a zip file, and which you can then use to the train model, you can consume it anywhere basically. Okay. And if you look at some of the accuracies, right, so this is something which is a reason for celebration for Microsoft guys. So if you look at the accuracy, ml.net is around 93% accuracy, as opposed to scikit-learn and h2o, which are the other auto ml low code no code training frameworks available out there. And if you look at the runtime, which is training and testing, in minutes, ml.net achieves 93% accuracies only with the 11 minutes of training, as opposed to, like, 85 and 125 minutes of training for scikit and h2o. So it's high performance, it's extendable with TensorFlow, Keras, and more. It's custom ML, and also made easy with Auto ML. Okay. So, I mean, how do you proceed with ml.net is basically you will have the ml.net context. Okay. So, if you look at the ml.net context, it is nothing different from how you create your DB context in your entity framework, right? So, .NET developers will know what I'm talking about. When we are consuming entity framework models, we generally operate with the data DB context, right? So, this is the ML context, which will in turn give you a handle to all the other machine learning libraries, like predict is there, load is there, hyperparameters is there. Okay. So you create that context, you will load the data from your source data, you will transform data, like if there are some null values to be removed, or there are certain yeah, scaling to be done on an unbalanced data set. Okay. Choose algorithm. So which algorithm, like if you are wanting to do linear regression, then is it XGBoost, or I mean, the flavors of lasso regression, or all those things, right? When you choose the model, you train the model, you evaluate the model. So there's a quick, like you can give a quick couple of sample test data and quickly see whether it is up to the mark or not, and then otherwise you can retrain it. Okay. And once you're satisfied, so once you've evaluated your model and you're satisfied with the accuracy and the amount, the type of prediction it is giving out, then you can deploy and consume the model. Now, mind you, all these steps can also be done via code, right? So how you do your entity framework models, you can create the database context and the entities and everything from scratch, right? But then also, again, you can have the directly the EF designer, wherein you can drag your connect to your database, and then you get your schema, and from the schema you can generate the entities. So again, same thing, like for again, for quick wins. So see, when we talk of auto ML, right, low code no code situation, those are mostly for your BD opportunities, business development, or POCs, or quick wins, wherein you can quickly demonstrate to a client that, hey, I can set this up, and this is what I intend to do. So if they want advanced analytics, and they want some sort of forecasting on their data, what sort of forecasting is possible? So just quickly consume their data, show them the possibilities that their data has, right? So those sort of low code no code things are there for us to quickly set something up, quickly get our application running, right, without putting in a lot of effort, like creating environments, downloading libraries, and putting in all that effort for just a small application or a small POC sort of thing, right? So So all these steps are can be automated as well, right? Okay. So before we move on to the actual auto ml, right, so there are a lot of FAQs surrounding, because there's as I mentioned, like two flavors of auto ml. One is from the Azure Machine Learning Studio, one is ml.net. So normally when I demo these two things, I get asked this question a lot, like what is ml.net used for? So we know that it's like a machine learning for .net programmers. What type of applications can I deploy ML models to? So ml.net is cross platform. Doesn't mean that if you create a model with the ml.net, then it can be used only on Windows. No, the final model zip file can be consumed anywhere. What frameworks can I use? So it is .net core version 2.0 and above, right? And for normal .net, it is version normal .net framework, it is 4.6.1 and above. What architectures are supported by ml.net? Both 64 and 32-bit. OS is because it's based on .net core, so it is Mac OS, Linux, Windows, cross platform. Is it free? Yes. Best programming language, it is currently supported for both C sharp, F sharp, and very you can just quickly get started with the tutorial very easily. And how you can install ml.net? So if you're using Visual Studio 2019, then I think you just, I mean, you need to have the NuGet package. Sorry, if it is Visual 20 Studio 2017, you need to have a NuGet package. If it is Visual 2019 version 16.9 and above, it is included by default. Okay. How it is different from other AIML offerings? So ml.net is auto ml for .net. Azure ML, which we will see, right, for one of the classification auto ML cases. So that is on the Azure portal. Okay, so it is like generating your Python code on the fly. I mean, it's like instead of writing Python code to load and transform and all, let the portal do that, right? So let the portal load the data set and let the portal generate the experiment and Python export experiment and files and stuff like that. ml.net is let the Visual Studio do the heavy lifting for you. All right. So there's cognitive services as AI as a service. ml.net is machine learning for .net, and Azure machine learning is basically leveraging the cloud platform for all your machine learning needs. So writing Python notebooks and leveraging Docker images of operating systems and other packages from the cloud ecosystem itself. All right. So let us quickly now, with all these minimum introductions, let us get up and running with our demo. Okay, so first will be with the using the ml.net itself. Okay, second would be with using the, sorry, sorry, yeah, so let me, come on. Okay, fine, yes. So first would be using the Visual Studio. Okay, so ml.net, right? And next would be on the Azure portal, and if time permits, we'll also look at custom vision, or I'll show you the basic framework or skeleton for getting up and running with custom vision. So let's get started. This is nothing. First, I mean, just to put it into perspective, right? So initially there was nothing. Okay, I just created a sample normal .NET Core console application. Okay, so let us imagine that initially it was just a console application, hello world, the basic thing which comes out, right? So here there was just console.writeLine and hello world, right, for example. So that was the only thing. This normal plain vanilla simple console application, hello world console application, we are going to transform into a machine learning application that is going to help us to decide about text classification, which is like a sentiment analysis, whether a given tweet or a review is offensive or not offensive, right? Whether sentiment is positive or negative, a binary class text classification. So we are going to transform this vanilla simple console application into a smart machine learning application in like few minutes. All right. So this is my Visual Studio. Is, if you look at that, if you look at the help and about, right, so it is Visual Studio version 16.11.2, right? It's 2019 professional. Okay, right? So let's get started. Mind you, if you're using community free version, ml.net workloads are not available, right? You need to have professional or enterprise workloads for that. Okay, so let us go here and sorry. So now this is our normal, console application. You will just right click here and you will say add, like how you add existing item or how you add new projects to your folders to your project, and you will directly say add. Tada, machine learning. You will get here a tab for machine learning, so add machine learning. When I click here, then there are certain scenarios, right? So there are certain like value prediction will be there given past values, like linear regression, right? So you predict the future. Limited scenarios will be for anomaly detection, forecasting, clustering, object detection. Okay, and I mean, if you look at these examples, most of our use cases fall in either of these. I mean, apart from the higher order NLP models where you want to extract out relationships, or where you want to label PDF forms and stuff like that. Apart from that, most of our normal use cases like object detection, image classification, value prediction, will clustering, forecasting will time series forecasting and all will fall under these scenarios. And which means it's immensely helpful for me to just quickly select a particular scenario and just get my ML logic ready within no seconds, right? So I'm choosing text classification here, right? And then of course local train locally on your machine. Okay, next step is getting the data. So my data is, I will be choosing a file which I have made myself available, which is the label text from Yelp, right? Okay, so I'll be selecting that file, select a file. And oh my god, okay, I need to go to, right, let us go here. Let us go to repos. Let us go to MLNet demo. Yep. And let us choose the file which is available to me. So this is a text file which I've downloaded. Now, if you look at the file, there will be two columns, call 0, call 1. Okay. So I'm going to predict. So I'm going to predict the column 1. Okay, so if you look at the file, it is like column 1, which is the sentiment, positive or negative, and column 0 is the text, right? So what I have to finally do is, given a text, I want to predict the sentiment, right? So what I'm going to predict is the column 1. Input columns are the feature columns. So predict is the label. I'm going to predict column 1, which is the label, and column 0 are the features. Could be multiple, right? So right now it's just a sentence. It could be multiple features, and then you will have feature selection algorithms and stuff. So this is just a preview of our data, right? So what the Yelp file has, the Yelp label text file. So it has column 0, wow, love this place, and the label which is positive, yes, it's a positive sentiment. Crust is not good, 0, it's a negative sentiment, right? So it is your sentiment has been converted to binary 0 1, and this is your text. All right, so now you've done with this. Now you will, of course, like, you've got the data. Fortunately, we didn't have to clean the data or anything, so otherwise, in your normal file won't be as clean. So you will have sentiments which is positive, negative, neutral, that you have to do one hot encoding and convert it into some sort of encoders, and text is there. Okay, so all this is done, then we train our model. That the time to train could be like 20-30 seconds, anything which you would feel which will benefit, but it's a very small data set, right? And in the interest of time, let us keep it at around 20 seconds. So let us keep it for 20, or maybe let us keep it for 30 seconds. Okay, okay, and then we start training it. So here itself, if you see, if you look at the, let me show you the output here. Actually, here you will be able to see the training, what it is trying to give you, right? So iterations, what model it is trying to choose, what model it is trying to do. Okay, so maybe in the window we need to check window. so it is trying to do something. Right. Right. So it has it has iterated, like, evaluated few models. Finally it has uh, zeroed down upon average perceptron ova as the best model because it gives the greatest accuracy. The training time was 13.41 seconds. The total models explored were only this guy alone, right? So maybe if it was more, like if you had given it for 60 seconds, maybe it would have explored more models. Accuracy is 81.6% here in this case. Maybe, we can try testing for maybe around a minute. Let us do that, just to, so that, I want to show you the number of models it is actually evaluating, right? So maybe here, by the time, let's look at output window. Okay. Right. Let us look at the output window here. Okay, so here now you see that it is still zeroing down upon average perceptron nova as the model, right? The best accuracy is still the same. Here, next step, we will see evaluation of the model. Maybe we can check the output here. Okay, let us look at the output. So this is the output from machine learning, where it will show you what it has. Yeah, so here you can see all the models. Say it's a it evaluated these models: average perceptron, SDCA, maximum entropy, right? And then when you gave training time as 60 seconds, it evaluated even more models here. See, SDCA, maximum entropy, light GBM multi, symbolic SD, logistics regression. Okay, all of these things. And finally then it has, here, light GBM multi. Okay, and then finally it has zeroed down upon something based on the best accuracy which it has found. So here, see, average perceptron has the accuracy of 81%, and that's why it has. Okay, so let us evaluate. Right, so let us evaluate the model. In the evaluation step, what are you going to do? Basically, you're just going to give a test sentence, right? And then you're going to see what is the prediction. Okay, so there is some placeholder text given for you, but maybe, maybe we can just give something and then say predict. So which is like, it is a negative sentiment. So 97% the get lost is a negative sentiment. 3% it is saying it may be positive. So 97% it is confident that the sentiment here is a negative one, right? It's offensive. Okay, so maybe right now, like, if you see that, okay, I'm satisfied with my model, and then you can click on the code tab. Okay, once you click on the code tab, what happens is you will basically get two projects added to your solution. One is the console app and one is the ml.net model. The ml.net model itself is nothing but the model class. Okay, but the model input and output, what is the input, what is the output, the machine learning train model.zip file, which you can, use it on consume it on other platforms as well. So you can use this train model and then use it in your Python notebooks if you want to. Okay, consume model is our the model which gives us a handle on the prediction and input output, right? And console app is basically a skeleton program which shows us how to consume the data. Okay, so how to actually leverage the machine learning model and how to consume the data and predict the outcome. Okay, so this is a console app which gives us the bare minimum basics of how to act with how to interact with our machine learning model. Okay, so ml.net, if you go here and if you look at the program.cs file, right? let me close this guy. Right. So if you look at this file now, our normal console application, taking hint from the console app here, the ML demo console app, what we are trying to do is we are trying to give a sample data, and then we are using the consume model, which is consume model, which is generated by the code itself, by the ML machine learning .NET framework itself. And then you're using predict. So the prediction function is there, which is, that prediction function, if you go and look inside, it is actually, yeah, so this is actually calling the prediction engine and generating the ML context. Then it is taking the model path, which is the zip file here generated. Okay, then there is a transformer here which is loading the path, and then it is taking in the input schema and then returning the output. All right. So much the same way, you're just consuming the sample data, giving it here, and then based on the output, so result or prediction, if it is 1, then the sentiment is positive, otherwise the sentiment is negative, right? And if we just run this program, it is basically going to, so it is basically going to give me a window, console app, and then it will take the data which I have given to it, like wow, this pizza is wonderful, or get lost and stuff like that, and then going to do my bidding. So it is going to give me some sentiment here. All right. Yeah, so this text was, this restaurant was wonderful, sentiment is positive. So quickly, I mean, how easily we were able to consume a machine learning workload here in our normal console application and turn it into a wonderful text classification application within no time, right? So that is one of the, I see as one of the most winning points of cloud based or auto ML, cloud based AI or auto ML with whatever editors, maybe it AWS or Azure or whatever that is, right? So this is one of the epic wins of AI in my view, that how quickly you can, I mean, as if you're installing a software, right? I mean, you just click on the executable and it guides you through the installation steps. So that in my view is one of the uh, biggest wins of AI, right? Another case which I want to show you is by the usage of your Azure Auto ML. Okay, so for the Azure Auto ML, basically what you have to first do is, right, sorry, for the Azure Auto ML, your requirement initially is that you need to have a machine learning workspace in your Azure portal. So you need to create a machine learning workspace in your Azure portal, and after that, you will be able to launch the machine learning studio, right? So this is your machine learning studio. You need to have a machine learning workspace. You need to give it your resource group name, the region in which you're hosting, and XYZ. Okay, and then then you will come to this machine learning studio. In that machine learning studio, here you will see that you have all the menu items here. Okay, where you have a notebook, automated ML run, you can create pipeline, data set, compute instance, training cluster, data store, environment, and XYZ things, right? So here we are going to create an automated ML project. Okay, so you can create your normal notebooks also. So as you can see here, I have certain experiments where I have my own object detection running. Okay, for my for some of my projects here. Okay, okay. So now if I'm going to create ML, so I'm going to create a new auto ML run. Then again, same thing like how we saw on ml.net, you will first need to select the data set. Okay, so this is going to be a classification experiment. Okay, so I'm just going to create here, so data set I'm going to create from, again, local file. One word of caution, only tabular data sets are supported for automated ML here. Okay, so from local data sets, okay, give some name here, say like test ml3. Okay, right, data set is tabular, some description. When you go next, okay, so it will ask, it will create a new data store. Okay, and then I will be uploading. Okay, so upload files, and then it will ask me, and I've already downloaded the file here, and this is my bank marketing. Okay, so this is my CSV file. Okay, and then I actually, I mean, I don't want data validation. Okay, for all of you who want to actually look at the creation of the ML, automated ML using Azure, right? I'm going to send this particular yeah, I'm going to send this message out, and maybe Vishwas, you can send with share with everyone, right? For the automated ML. All right.
Sure.
Okay, so coming back, right? So I'm following the instructions which are there, right? So I've uploaded this, okay, and we are not going to do any data validation, okay. Then we do next. So it is parsing the data set info, right? It is a very simple, it is a very small file, right? It's only maybe a 3 MB file, correct? And then what is the file format? It is data limited. Files have headers, yes, correct. And then okay, let us look at here. So correct, when we are loading the data set, okay, and then data store create, right, browse, and then unique, correct. Okay, delimiter is there. Okay, value should be all files have same headers, and then skip rows, right? So just have a look at these settings here. Okay, those same settings we are going to follow. Skip rows, none. Multi-line data means sometimes, you know, your data is distributed in different lines, right? Because it's a big file, or it has a lot of hundreds of rows and stuff. Okay, so this way, like, you know, for example, my data doesn't contain multi-line data. Okay, right? And then these are the I mean, basically, you know, this is your data set configuration. Okay, and then here it will give you like which columns you need, and depending on the columns, right, it has also selected, it has automated the type also. Okay, okay, and then you can also, if you see this toggle button here, you can decide like which columns to exclude or which column to include here, correct? So education, loan, contact, month, day of the week. So here, if you look, if you look at the tutorial, day of the week is some feature which we don't need. Okay, so all these things which you are seeing here are the features. So these column names you are seeing here are features. Okay, out of normally, you know, as data scientist, you will know that whenever we are doing exploratory data analysis, that time we are checking like which features actually you know, have the most bearing, feature importance which we call, so have the most bearing on the model, which are directly proportional to the outcome, which are not you know, which have correlation, which have a strong correlation, those sort of things, right? So a day of the week I'm not going to choose, maybe because it doesn't matter much. All right, correct. And then I'm going to do next. Okay, so confirm details, file settings, blah 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 blah, all of these things are done. Okay, this is like profile this data set after creation, I'm not going to set it. Okay, and then I do create. So my data set is created. So this was successfully created, correct? All right, then okay, so here it's just like your list, right? If you update, if you refresh here, so yeah, this is my data set which is created, correct? If I click next, yeah, I need to select this data set and create next. So now after my data set configuration is done, I have to actually configure a run. Okay, so when I'm creating a run, it is like, are you going to select an existing experiment or creating a new experiment? So I'm going to create a new experiment, saying this is test auto ml. Okay, now target column, what is the target column which you have to predict? So this is the target column which you have to predict, right? So which target column are you going to predict? So again, if you go back, correct, So select Y as the target column, what you want to predict. This column indicates whether the client subscribed to a term deposit or not. So this is a banking transactions data set. Okay, and then we have to we have to classify whether this, given the transaction details, the client is subscribed to a term deposit or no. Okay, so when we are going to, so this one, right? So this is your target column, correct? Okay, compute cluster is the cluster which you are going to for okay, so this is compute cluster is your compute instances that you are going to assign. All right, so which means this is can be something like, for my workspace, they were already create present, so it is like the number of nodes and whether what sort of machine it is, GPU, CPU, right? So I already, I assigned a compute cluster. So if you see here, if you information will be here, training cluster is required to execute the run, right? So resources, basically what are you going to train your model on? So these are the resources, so which will have the number of cores, machines, RAM, etc. So I have a custom, I already have a compute cluster which is super powerful. It is a GPU based, and I think it is 16 core and stuff like that. Okay, so just remember that when you're using your free resources or your free subscription, there's a limit on the number of clusters you can use. And after your experiments are created and done, be sure to shut down your cluster, because running clusters will it incur cost. Okay, now select the type of task, which is, so here it is classification, whether to enable deep learning or no, right? So when enable deep learning, here it is helps to featureize text data and may provide higher accuracy, right? So again, if you enable deep learning, that is going to incur time and costs, right? So this is your compute clusters. Once it is done, right, then yeah, so these are the these are the settings you are going to do, correct? Okay, so go back, right, enable deep learning, time series forecasting. Once you've done here, okay, and then here you have additional configuration settings and view featureization settings, right? So if you view the additional configuration settings, you can select the metric here, primary metric, AUC, weighted explain best model, yes, which means once it has taken chosen a best model, like in the ml.net we saw that it came with the perceptron weighted perceptron OR, right? So here why it chose the model which it chose, right? So why it chose XYZ model, why did chose light GBM XGBoost. Okay, and here it is a list of blocked algorithms. Okay, so you can choose like which algorithms it should not use for your classification task, right? So here you can click, well, you cannot select anything, which means it will iterate to all of them and then it will choose. But you all of us know that for classification and all, so light GBM, light gradient boosting machines are the best. Okay, followed by your random forest. Okay, so you can blacklist algorithms which it should not try at all. Okay, so that your training is eased up quite fast. Okay, it is done quite fast. But let's not even, let's not block any algorithms here. Okay, maybe SGD will block here. Okay, all right. And then what is the exit criteria? The exit criteria, right? So exit criteria is the training job. What is the training job in hours? The metric threshold score, what is the metric threshold score after which it should exit out? So I after training for XYZ amount of time, and then after coming out, so maybe for our, because our data set is not too huge, maybe it is okay, so it's a quarter of an hour, right? And metric threshold, set the metric threshold to whatever you want to. Okay, validation, auto concurrency, whether you want to have concurrent runs or no. All right, okay, so this is the exit criterion. And you can have metric threshold also. For classification, it is area under the curve weighted. Okay, you can have, and you can have multiple metrics also here. Okay, so once it is done, you will save it. Featureization settings is when you say featureization, it will try and give you, like, what was the feature importance. So when it was calculating your model, what were the features that had a direct bearing upon the model and its accuracy, and which feature was given importance in the best model that was selected, right? So this will be this will give you, like, the feature importance right after the model is trained and is available, right? Okay, so with all that in place, your features and everything, okay, then uh, you will click on finish. If you want to enable deep learning, you can do that, right? And then you can click on finish, and then it is creating a new automated ml run. And it in the background, it is yeah. So here, for example, once now your experiment is under progress. Okay, so this is the iteration one of your experiment. This is the first run of experiment. Okay, and now you can see all these things. So once your so this is started. Okay, details, it is started, and it's not yet started, it is still scheduling. Okay, and then once your run is finished, you will see that it is what is the best model summary. Okay, and when you look at models, it will give you, like, once the models are ready to display, it will give you, and you can click on explain model to see, like, the model explainability, like what was the accuracy, why it chose this model, uh, what metrics were there, like AUC was the metric which we chose, and AUC was the highest in this model, so that's why it chose this model. So it will give you all those details. Okay, so best model is there. Okay, featureization is auto, primary metric is area under the curve for classification. Okay, and then you can also see few charts here. Okay, so here when you look at the explain model, you can see some charts and graphs also telling you feature importance, and these are the output logs which will be like if there's any errors, if or uh, which run I am in, and all those things. Yeah, all of these things, right? So it's pretty how should I say, neat in the way. And plus you can see child runs. So under, so for example, under one particular experiment, if I have multiple runs, okay, so this is run 1, run 2, and stuff like that. Okay, if it is concurrent, so it is batch processing, so all of that will be like shown to you here, correct? Right, so this is my run 1, and then keep on refreshing this. So this is going to take up time, right? So now you can see that it is setting up the run, and again there's no best model summary because the best model is not yet available. So yeah, let this run, and then that is how your experiment pass, fail, and everything will be logged there. Okay, so if you go to experiments, you can see that this is my experiment which we created. It is the latest run, so this is only the first run. So you can see other experiments where I have like 54 runs, right? And then I can actually go inside and see all those runs, see completed or not. Okay, I can resubmit it, right? And then I can see the fairness. Okay, it didn't have any. Okay, and the metrics. Okay, so this is so view as, so if you, so the metrics, right, you can see as a chart or a table. So loss value was my metric here, and then you can see that it as a child or as a chart or a table. Okay, right? And then you can see the min max. Okay, here you can have explanations preview. So right now I did not enable any because this was not my auto ml, I mean, mind you. So these run which you saw here, experiments in the duck detection, these were classic your Python custom vision object detection. Okay, so these are not automated ml. So if I could have enabled model explainability and other stuff for those as well. All right, so yeah, so if you look at now my auto ml here, it is running. Okay, it's not yet completed. And then you can also see a lot of metrics here. See, so you can add chart for your peers to review, like what were the number of runs, how many number of runs failed, what was the accuracy. So all of those things include child runs or not, view only my runs. Like for example, if you have a lot of data scientists working on one particular project, right, and then you want to view only the runs which you have scheduled, then you can do only that. So even in those things you have a lot of a lot of uh, options to go for. All right, so yeah, this is going to take time, right? So this one, okay, run when it's running. Okay, so this is going to take time. Once you go here, yeah, so setting up the run created, and then you should be able to see all of these things as well. So on the experiment side also, you can do a lot of monitoring things, and then on the actual run side also you can so this is like as I said, on the experiment side you can see charts and edit columns. Okay, so instant type, modified, node count, parent, run id, all of these things also you can select. You can export them into a Power BI dashboard, right? Okay, so yeah. Okay, so our runs are now, what is happening? Okay, maybe we'll do that. Correct. Yeah, and then yeah, right. So maybe so yeah, and then let this be right now as it is. Okay, so as the ml.net, you saw this is a bit tedious because I have given 0.75 hours, almost like 45 minutes as training time, so we don't have time to check this out, right? But then yeah, you can actually go here, follow the instructions, set up your machine learning workspaces, and see after 45 minutes what is the model which it comes out with, and what is the AUC score, and what is the accuracy, right? All right, correct. Same goes for the custom vision as well. We are running out of time, but then same thing is you have to sign into the custom vision portal, right? You don't have to. So this is your classification, right? Object image classification project. So there you have to just sign in. So this is a custom vision.ai. You need to sign in with your Azure credentials, create a new project, like how we created a new machine learning project in portal, upload your images. Okay, and then you actually tag images, like this image is a dog, this is a cat, and this is a giraffe. Okay, so at least 5 images of a type are needed. So annotate at least 5 dog images, at least 5, and at least 5 cat and 5 giraffe. You train them, and then you will be evaluating. Okay, so like for example, now any third, like any like for example, if you show any other image, like maybe like a rhinoceros, for that matter, right? Then it should try to predict it, or then you can also introduce a new label saying none, like none of the above. So that is automatically included as a third, I mean as a fourth separate category. So either it's a cat, dog, giraffe, or none. Okay, or other category. Okay, so that is also, like while evaluating also, you can tag your images and then retrain your algorithm, right? So all that is facilitated by the portal itself. Okay, so you can visit this customvision.ai portal. Okay, again I'm going to put it on the chat window here. Alrighty, cool. So that brings me to the end.
Yes,
All
ma'am.
right.
Thank you so much. And hey, guys, just a quick note of some failures which I saw, because that would really give you some insights about like why do we need to learn AI. So failure in AI is failure in humanity. That's the new way in which AI machine is built. Why? Because let me just say something like, you have a person who is suffering from a diabetes, and you know that in a city there are too many diabetic patients there. So what happens is, somebody has an access to that data, and they want one city to suffer, which will affect entire humanity overall. So that data affects people. So this is how much it is. And if there is a data of somebody who is like, the list of people who are having pacemakers, something like, this is the column which has some list of pacemaker, and they target that city as well. And it's very simple to even destroy an humanity. Just pass an electromagnetic wave, it starts killing every person. So in a meanwhile, that's how physics and the AI works together. So in a meanwhile, this is one of the biggest software disasters that really happened in the world of software engineering, because Ariane 5 rocket had this controversy. Something as good as, there was around 55 to 60 different complex functions and things like that. What really happened was, there was a software which was in 16 bits, And now it was compiled as 32-bit, but ran on a different machine altogether, which was not supposed to be ran. And what really happened was, instead of rocket moving up like this, it just tilted like this, and the aerodynamic stress happened, and it really burnt into pieces. Loss of $400 million. And if you think of something like, there is something called as bit flips. If you want to really understand what is a bit flips, it's nothing but you have an entire compute system which goes in computing ones and zeros, and something like 8421 notation. That's what your digital electronics and things like that. What if I convert this to zero? It will just become eight, and this will really change the amount of computation. What really happened is there is something called as hardened components. That's what they use in rockets as well. And I would say next one is the list of something which really shaped me back and said, "You're not the boss in this field." Because this is a tweet from Godfrey Intern very long time during the pandemic, where we all were sitting in the house and we were all thinking, hey, his theories are much more greater. And he himself tweeted that there is a flaw in whatever I had as an idea. And one more thing is like, this actually came across to me when I joined engineering. This was the year 2017. Facebook shut down its entire AI project because their AI system started talking in their own language.
Correct.
There's a proof about that article here. So if you want that, you guys can go there. But I was amazed by the fact that they even gave out a package called as QNN package, quantum neural network pack, exactly 6 months later. This is exactly 6 months later. This is in the year 2018. They gave this quantum neural network package, which is still an archive package now. Nobody uses it, but yet this marked the history of quantum neural networks coming inside the deep learning through the PyTorch team. I think there are amazing people like Supriya, or else there is Renukantala, there is almost other people. You guys can follow them, and they are really good. And the hottest topic today is the self-driving car. Uber accident lawyer was this guy. There are hundreds and lists of accidents that have really happened, but you know what? Elaine Hesberg, her death really caused an history in the world of self-driving cars. That means it was just, I'll say you what really happened there. It was just a processor which was supposed to be taking images of R, G, and B, red, green, and blue, but started convolving in a different fashion. And there was a new way in which the computation happened. That's where the self-driving car went crazy and it started killing a lot of people. So
Right.
Tesla has a lot
No,
of crashes.
I want to also add on to that, Vishwas. For
Yeah.
example, so I was actually, driving for one of the AI sessions somewhere last year, okay, and I
Yeah.
was having a conversation with the cab driver who also happened to be working in the tech field quite some time ago, right?
Mhm.
So he was telling me that what happens if you have driverless cars, or tomorrow all these robotic cars and self-driving cars come into picture. That will also shape your insurance, your
Yeah.
accident insurance, car insurance industry, right? Your personal insurance.
Yeah.
Because if accidents happen, whom do you blame?
The
And how does
companies.
it work? How does it work? Who is the ownership? Right now it's like,
Yeah.
you will claim, like, claim for damages and stuff like that. But then in the case of a
Yeah.
robotic incident, how are you going to claim for damages? Are we
That's
ready
what.
for that sort of overhaul and total, change in our dealings, right? Finance
Yeah.
industries and stuff. Okay. Again, another thing is, now algorithms or programs work on predefined routes, right? So from A to B. So if I'm
Mhm.
going from airport to, let's say, to city to airport, but what happens if the person has a sudden heart attack, or is in
Yeah.
need of medical emergency? How can the car sense and reroute? Because reroute for me would be a disaster, in the sense that it is, if it works on reinforcement learning and always tries to optimize things, then that
Mm.
optimizing, now rerouting will result into less rewards, right, for that
Yeah.
algorithm, and then it might not want to reroute. So how do you program that instinct, like I have to reroute and treat this leave this patient at a hospital, or those sort of things. So
Yeah.
there are a lot of things in which AI is making strides, but then the scenarios in which they are used are very limited. So auto driving driverless cars might work in a scenario which is like, you have Disneyland or water parks, where you want to commute
Sure.
from point A to point B, and you know that it's a small distance of about couple hundred meters, and this is the landing point, this is the departure point, right?
Mm.
So yeah, I mean, all said and done, as said, I mean, I would reiterate, even in this session, like I did in the earlier session where I was talking about
Earlier
Amazon
sessions.
AI, and yeah. So AI is here, is going to be here. We need to reskill, upskill, and we need to coexist with it. Okay,
Coexist
so
with
it's
it.
not
Yeah.
going to replace us, and it's up to us how far we are willing to invest and make it robust, right? So we better
Sure.
harvest it for good things. So like Tesla is doing,
Sure. Yeah. Yeah, somehow they are just annotating the data set and now getting a lot of insights. But
Yeah,
there are some pitfalls in those models as well.
of course,
But
of
if you want
course.
some more insights about cyber part, I think Ghost in the Wire and Wired for War, these are some of the best ones. And you want some more instance about AI, you all know Harari's book is amazing. I've read
Yeah,
Sapiens. Sapiens is amazing. Just read that, people. Sapiens is saying mostly about evolution of the brain over a course of time and how humans evolved and things like that. And also, yeah, ma'am also really point out to one thing which was very cool, which is about insurance and the things like that. Asilomar principle was signed during the year 2018 or something. I was in second semester almost, yeah. And that's the time where they signed about this. This is an actual pact which all the
yeah,
AI
correct.
researchers and everybody is
Right.
signing
This
it
is like
today.
your ethical AI framework and
Yeah,
responsible
ethical AI
AI, right?
framework.
You can also read about a book called as Broca's Brain,
That's an amazing
Carl Sagan. Okay, so I urge you to read about Carl Sagan. Yes, Carl, Carl Sagan,
pulsing.
right? And then you can read about that book, Broca's Brain, wherein he talks about two dimensional. If what if the world was two dimensional, right? And what if it was more than three
Mm,
dimensions? How to think in more than three dimensions? And that is how actually PCA algorithms work.
yeah. I think Vitalik Buterin came out with this algorithm called as SVM, but today it's beyond it. But
Yeah.
SVM has been extracted to beyond it. And there are a lot of things, folks. If you have some list of failures, do comment it down in the comment section below after this goes live. And yeah, I think thank you so much. I think Poonam has two questions. Ma'am, we can address that.
It predict rare. Yeah, this is outliers, right? So you have rare events, so you have anomaly detection. Can
Yeah.
use that, right? And training limit. What is training limit
What
in
is the
Azure?
training
How?
limit in Azure? Oh, well, how
No,
can
I
it
mean, it
be?
is no, no. See, if you're using the portal, it can be anything. The compute cluster size dictates it, right? So have a big enough compute cluster, and you can train for thousands of epochs, which is normally the case when you do with custom vision models and higher advanced analytics models, right? So there's no limit as such. It is constrained only by your compute cluster.
Yeah, I think that's it, folks, from our side. I think thank you so much for all your time and patience. I think AutoML is something which is not hyped or hope, but it will somehow be a part of your journey in the tomorrow's
Right.
world. And thank you so much, Priyanka, ma'am, for this final session.
Thank you. Take care. Stay safe, and have a good
Bye.
day.
Bye, folks. I'll end the